This lesson is basically a review of trigonometry, so there shouldn't be anything new, but I won't judge you if you've forgotten some things from a year or two ago. We have our sine, cosine, and tan ratios, okay, which we can use to solve triangles and solve problems. Notice that for all of these triangles, we need a right angle in there. So if you look at the front of your booklet, we're dealing with things over here. So does the angle contain a right angle? Yes. We're over here. What sides are involved? I can put my three ratios down the bottom here. Okay, we've got right angles. It involves an angle in some way. We're using sine and cosine. If we don't have an angle and it's a right angle triangle, we'll be using Pythagoras. Okay, this diagram is going to guide us through this unit. Okay, so let's go ahead for a super quick review. I've got an angle here. This is the opposite side. This is the hypotenuse. So I'm going to use the one that relates all of these together, which is sine. Use the sine rule. I'll write my rule. Substitute in the values I know. Opposite side's d, so I'll leave it as d. Okay, and then solve for the unknown. Need to multiply both sides by 58. Okay, and then it's calculator time from there. Remember, when you turn your calculator on in Shift menu, make sure that your angle is in degrees, and then you can just type it in. Okay, 33.27. That's the length of that side. Is it reasonable? Well, yes, because 33 is smaller than the hypotenuse. Okay, so make sure you check that it's a reasonable answer. Okay, next one, I've got degrees, minutes, and seconds, but I'll treat it exactly the same. This is the adjacent side, and this is the hypotenuse. So I'll be using cosine. I'll write the rule, as always. Substitute in the values that I know. Okay, and now it's interesting, I've got the unknown on the denominator, but that's okay. I'm going to multiply both sides by n. Okay, and then I'm going to divide both sides by cosine, whatever it is, cosine 29, 35, 55. So n will be 78 divided by cosine 29 degrees, 35 minutes, 55 seconds. And then it's just calculator time again. So 78 divided by cosine 29. When I want degrees, minutes, and seconds, options, F6, angle, I'll use F4 for all of these signs. 29 degrees, 35 minutes, 55 seconds. And it'll give me the result directly, 89.71. This is the distance, okay, and it looks okay because this distance is bigger than the adjacent side, okay, because we're finding the hypotenuse. If you've got an angle, say 50 degrees or 50.25 degrees, and you want to change it into degrees, minutes, and seconds, just press execute, and F5 will get you there. And you can not switch between the two. Okay, you just get one crack because you can see the answer there. All right, so final one for review is finding the angle. So unknown angle here. This is the opposite side. This is the adjacent side. Using tan, write the rule. Okay, right, substituting the values that I know. So I know 2.6 and 3.7, and now solve for the unknown. The unknown is this angle, so I'll inverse tan there to get rid of tan. I don't want to see anyone doing 2.6 on 3.7 divided by tan. Put it in your calculator, it won't work. Okay, inverse tan to find angles. Okay, Calculate time. Get an angle of 35.1 degrees. Okay. Always just go to 2 decimal places for all of these with your rounding. Okay, so that's a review of how to use right angle trig. Also just quickly review some of these ideas that you'll find in a lot of the problems. So an angle of elevation describes a person, say they're standing on the ground. From their horizontal view, what angle do they need to look up? In the same way, an angle of depression, they could be on top of a tower or a hill looking down on something. Their normal horizontal field of view, what angle do they need to turn their head down? And because of this Z rule, we know that the angle of depression and the angle of elevation for the same scenario, so we've got 2 people standing here looking at each other, will be the same. So you can exploit that fact pretty regularly. So just a little bits on how we can describe direction as well. We've got 2 different ways. Compass directions is one. So I always start from either north or south, and it's measuring how far either east or west I need to go. So this angle, it's in the bottom half, so it's south, and we need to go 20 degrees east. Similarly here, from the north line, we need to go 40 degrees west. I would never write this angle as east 70 degrees south. Okay, it's never that. In a similar way, we also have true bearings. So start at north, which is 0 degrees. This is 90, this is 180, this is 270, and we get back to 360 degrees. Okay, measured from clockwise, measured from north in the clockwise direction. So have a go at writing these 2 directions, both as compass bearings and true bearings. So press pause, have a go. Let's see how you went. As a compass direction, this is south, and I need to go 58 degrees to the east. And as a bearing, I know that this is 180 degrees, so 180 minus 58 is what, 122, hopefully, degrees. And sometimes people write true after it. It's all good. Okay, over here is a compass bearing. Okay, from north, I need to go this angle to the west direction, so it'll be north. So in here is whatever 90 minus 13 is, 77 or something. Phew. And as a true bearing, well, I know this is 270 degrees, so I just need to add 13 degrees on there. So 283 degrees true. Any questions? Too bad. Using those skills, here's a problem for us to have a crack at from a rescue helicopter 1800 meters above the ocean. So I'll draw my helicopter. Angles of depression, so here's my ocean, to 2 shipwreck survivors, 60 degrees and 40 degrees. So I've got 2 survivors here. Call them, say, A and B to be creative. And I can mark on all this info. 1800 meters high. And I've got these 2 angles of depression. So from the horizontal, I've got 40 degrees, and the bigger one is 60 degrees. I need to label this whole diagram. So I'll put this vertical line in here. This can be H for helicopter, and this can be, say, Z for ocean. So part A, calculate how far apart the 2 survivors are. I'm going to assume that that's a right angle there. In part A, I need to find this distance. Okay. The real important part here is that we label our triangle correctly. I'm going to find that distance by finding how far A is from directly underneath the helicopter, and subtract that from how far B is from directly below the helicopter. Okay, so I'm going to have to use 2 different triangles. So I'm going to start by using triangle HZA, and I'm going to redraw that triangle so that I don't get confused in this massive diagram. 1800 HZA. Since the angle of depression is 60 degrees, I can calculate that this will be 30 degrees, and I'm trying to find that distance. So I'll go ahead and use tan to solve that problem. Now I'm going to use this result later on. I'm not going to put it in my calculator and get an approximation. I'll just leave it as that. I then need to find the distance from, so this is part A done, and then part B, I'll find the distance from Z to B. So I'm going to use the triangle HZB. Okay, again, draw it separate. Okay, I'll call that distance Y. I know that this is 40 degrees, so I'll solve this one differently and use the fact that I know angles of elevation and depression are equal, and I'll know that this angle in here is 40 degrees. So I'll go ahead and use tan to solve that again. The distance between B and directly under the helicopter. So now I know that overall, the distance between the survivors will be the difference between those two distances. The way we can, I guess, refer to things is in here I can say to find ZA, and this is to find ZB. So now that I want the distance between survivors, I can say it's ZB minus ZA, just to refer to those distances a bit clearer. So 1800 on tan 40 minus 1800 tan 30. Okay, and calculate it from there. Put it all in at 1105.93 meters. Is that reasonable? Yeah, it seems okay. The helicopter was a kilometre above. The angles are about 45 degrees. Seems reasonable. Part B, state any assumptions and their associated effects. So we can think of a whole heap of assumptions. Okay, we need to assume that the ocean is flat. What else do we need to assume? That the helicopter and survivors are in a straight line. What else? That they're staying steady as well. Okay, survivors not moving. Okay, if any of these assumptions were false, the effect of that assumption not being false would be the result or answer would be different. Okay, incorrect. So if any of those assumptions were broken, our 1105 meters would be incorrect. In the bigger problems, you're going to get absolutely lost if you don't label your diagrams. You'll have no chance. Drawing in 3D, it's really important that you label your diagrams. If I try and draw this diagram, 30 meters tall building due north of a building that's 20 meters tall, I'm going to get really confused trying to do this. Here's my 30 meter building, and then it's north of another building that's 20 meters. I can't see what's going on there at all. Okay, if this direction is north like it normally is, okay, that doesn't really work. Okay, better is to use a 3D compass rose where we've got 6 directions. North and south is 45 degrees backwards. East and west is where it normally is. And we have up and down. So to draw this scenario, I'll have my 20 meter tall building, okay, going up. This is the base of it. I don't give it any width, okay, because for most diagrams we just use a stick. And then north is this direction at about 45 degrees. So to the north, I'll have my next building, which is 30 meters tall, okay, using this 3D diagram idea. An alternative way of drawing this is to draw a 3D box, and then you can draw in whatever you want. So I want a 20 meter building, and then to the north, where are my dots going? I want a 30 meter building. So some people may prefer the box method so we can see where the right angles are. Just note that on this compass rose, between up and north is a right angle, between north and east is a right angle, that's a right angle, right angle, right angle, right angle. They're all right angles, even though they don't really look like they're right angles. So let's have a go at solving a problem. Two of the supporting wires of a flagpole are fixed to the ground at points A and B, which are due east and due south of the pole respectively. The wires are 10 meters long each, and the flagpole is 8 meters above the ground. Find these things. So I'll start by drawing a diagram. I always like to just draw my 3D compass rose, so I have it here to refer to. So I might just scribble over this with a different color. So I've got a flagpole fixed to the ground. So in the vertical direction there's a flagpole, and there's two things happening. One that's due south that's going to connect to it, and one that's due east that's going to connect to it. So my diagram is going to look like just that red part. So I'll draw it bigger away from that big compass rose. Here's my flagpole, 8 meters tall. To the south, there's a supporting wire, which is 10 meters long. And to the east is another supporting wire, which is 10 meters long. We've called these A and B in that order. This can be my flagpole, and the base of it, doesn't matter which letter you choose, H, for the hole in the ground. So let's have a go at the problems. Part A, find the angle of inclination of each wire to the ground. So I'm looking for this angle or this angle. I know that they're the same because their supporting wires are the same. So I'm going to use the triangle FHA to find theta. So I'll go ahead and redraw that triangle out of its 3D mess. Make sure I continue to label it. And I'll go ahead and use sine to find that angle. Okay, and that's part A done. Finding that angle, pretty straightforward. Okay, finding the distance between the points A and B. So this distance on the ground, trying to find this, call it X. Yeah, that might be a little bit more challenging, but I don't think we'll struggle too much. So I'm trying to use triangle BHA to find X. So I'm looking at this triangle on the ground, and I'm going to redraw it in 2D. Okay, remember, this angle in here is 90 degrees because it's the angle between south and east. So there's BHA, trying to find this unknown side. I don't know too much about trig, but I'm pretty sure if I know nothing about a triangle, I won't be able to find an unknown side. Okay, so what I'm going to need to do first is find either HA or HB. So I'll write down something like that. Need to find HA first. Okay, and I know that HA and HB are going to be equal because those two triangles were congruent. So I'm going to use triangle FHA again to find HA. So in this triangle that we used earlier, I want to find this distance. I'll call it Y. So I know all of these distances are Y. To use Pythagoras here, so in a different color, call this A, B, and C. I can go ahead and find that unknown side Y. So use Pythagoras. There's my rule, substitute in the values I know. 8 squared plus y squared equals 10 squared. Try to get y by itself. Remember, I should really be taking plus or minus square roots whenever I do. I'll end up with plus or minus. I'll end up with plus or minus 6. I'll reject the negative 6. So y equals 6. So from here, on my diagram, I can put my 6's in here. And now I can use Pythagoras to find x. Okay, so now I'll use Pythagoras over here. I might just redraw this so it probably follows a bit better. I know both of these are 6. And I can go ahead and solve. Again, I'll label what these are, A, B, and C for Pythagoras theorem. So, write my rule, substitute in my values, and then solve for x. Again, reject the negative, and there's my distance on the ground. So having a look at this, these 3D diagrams, it's really important that we draw them in 3D with a bit of perspective, and that when we're trying to solve for anything on the triangle, we redraw the triangle as if we were looking directly at it and show where all these right angles are. So here's a few questions to practice. I'd probably, unless you're struggling, focus on these underlined questions and also have a go at some of these 3D practice problems. Pretty sure these solutions are correct. All right, good luck.